So after you look at the descriptive statistics of your data, which we did in the previous video, which is about the mean, the average, centiles, and maybe some kind of a pivot table with the help of table command in Stata. The next, of course, is to look at graphs. And if you have not watched the previous video, what you have to do, you have to open this data code 1 Ames Homes. You have to obviously load the data and proceed to line 51. And the last example which I want to give in this graphs section, it's about creating a scatter plot for a few different values of a variable, and for that we will need to create a new variable, an indicator variable. And in the future videos we will look at additional details on how to create variables in Stata with the help of conditional statements. But here let's take just a very simple example. So there is a variable called overall qual, which runs from 1 to 10, and that's how the realtor evaluates the quality of that house. So the higher number indicates a better quality of a house. So let's create a variable overall quality 5+. So it will be an indicator variable which takes value of 1 if the overall quality is 5 or more, and 0 otherwise. So it just takes 2 values. And we write it simple, so we write this command generate to create a new variable. And so we provide the name of the variable, and then we put equal sign, and again overall qual more than 4. It's like conditional statement, and Stata will check if the condition holds, and if it does, then it will be 1, otherwise it will be 0. So if you run it, you can then open your data editor, and you can observe that this new variable has been added, and you can see that it's 1 for houses with overall quality 5 or more. And if you scroll down here, you see some houses which have 0. So for example, this house 655, it has overall quality of 3, and it has a value of 0. And alternatively, we can check this new variable which we created with the help of our tabulate command, right? So I want to compare my new variable to the existing overall quality, and here you can see that like basically majority of like 90% of houses will be in this kind of average or beta category, and just slightly more than 10%, those which are from 1 to 4 will get into this lower quality bin of the data. And the next step which we can do here, we can add labels. So we have just overall quality 5+, which takes 0 and 1, but we want to add some meaningful labels. And it's very helpful later on when we run some models or when we plot some tables, because we will be able actually to see a meaningful label instead of just 0 or 1. And to create labels for a variable, it's quite simple, but to create labels for specific values in a variable, it's a little bit trickier, right? So if you want to add different labels to 0 and 1 to our new variable, you need to take 2 steps. So the first step, you have to define the label. So I will have this label defined, and I will call this label 5+. So if it's 0, it will be quality less than 5, and if it's 1, it will be quality 5+. That's kind of the first step. And then I can reuse this label for a few variables, but let's just use it for my current overall quality 5+ variable. And by using this command label values, I can assign these particular new labels to the values. And you can usually check what has been produced by just typing overall quality 5+, and you see now that instead of 0 and 1, you have these meaningful labels. Of course, for coding, you will need sometimes to actually know how it's coded if it's 0 or 1, and then you can just add here null or no label, like null for short, and it will show you as before 0 and 1, and again that's the number which you will use when you create sort of additional variables. And let's also use label for the entire variable, not just for specific values, but for the entire variable. So let's replace this kind of boring label sale price, which we had here as a label when we loaded the data, to sale price USD. And actually that will save us a lot of time, because, for example, when we plot figures or graphs, or when we report some statistics, like this label, this meaningful label, will often be used. So let's run this line of code. And the last step, again, I want to do it for simplicity now. So we've seen that some houses really have large lot area. There are just like 5 of such houses. And let us drop them for now. They are probably some kind of outliers, maybe some kind of remote locations, maybe far away from downtown in Ames. And you can easily do it by removing this drop if lot area more than 60,000. And Stata will inform you that exactly 5 observations have been deleted. And also observe that in this section for variables, we have a new label, sale price USD, for the sale price, which is very convenient. So the final figure which I want to plot here will look at the relationship between sale price and lot area, but I will look at it for houses which are less than 5 and for houses which are 5 or more. And also this additional command total will provide me a total graph, right? So how does it work? You use, again, two-way scatter, then you have this, your standard sale price on vertical axis, lot area on horizontal axis, then you have these 2 symbols, then you once again have linear fit sale price to lot area, again you have these 2 symbols, put comma, and this new line will be what? By overall quality 5+, and also add these total, which will plot the third graph for the entire sample. And again, row means that we want to have these in one row and sort of not in columns. So let's have a look at this final graph, and you can see this relationship between sale price and lot area. You can see here that the legend now uses the label which we assigned to sale price, right? So we don't have to do it manually. We can see here that on the top of the graph, we have like 283 houses in this quality less than 5. We have one kind of relationship between these sort of lower quality houses, and we have a different kind of relationship for quality of 5+. Again, about 90% of our sample is in this part. And obviously the total resembles more like quality of 5+, because again we have the majority of our data here. So sometimes it's very important to look at extremes of your distribution, right? Maybe bottom 10% or top 10% to see whether the results are driven by these sort of extreme parts of the distribution. So I hope that you learned from that video that Stata has a very versatile opportunities for building graphs. I just provided you 2 examples, histogram and scatter plot, but with a lot of these extensions, right? Like plotting by a group, adding a line to a graph, changing background color, changing titles, and so on. And it works pretty similar for other types of graphs, which you will use in Stata. So thank you for your attention, and see you in the videos that follow.